Great.
Not long enough.
I'm so tired of spring break. Because my 3-year son is also in his spring break. So I was saying, I thought, let the spring break go fast. I need to go back to work. That's easier.
I brought my son to chemo.
Oh, no, really?
Nurse. Can't wait for him to picture that. We took Thursday and gone all day. We went to the beach and took pictures. We went to the strand. A big old chess set out there, yeah.
Oh,
Took
yeah.
pictures of us playing it.
Oh, cool.
I had a professional photographer with us all day.
So where'd you go?
I can't wait till it's come back.
I didn't go anywhere. I moved into my sister's house like 3 weeks ago. Or not even that. And I'm just getting settled in. And I was like, you know what? I'm going to be here a while. I decided to build a garden. So I've spent most of spring break digging outside, building a frame.
Plenty of water this week.
Oh yeah, I bought a rain barrel. I put up gutters so that I can collect rainwater for the garden.
That's a good idea.
Started a compost pile.
How big are your barrels? 55
It's a 65 gallon drum.
You know you can make a pool out of that thing too, or a pool filter system.
Full filter system out of a rain barrel. Like that actually catches rainwater?
No.
Or you could just like build apparatus like using it
Yeah,
as
you
like a
put
container.
a pump in there, or get a submersible pump in there, and you fill it up with lava rocks, and then fill it up with water, and like, I'm cheap. So in my backyard I have a push bottle that's like cool. Everything, and then it sucks out the bottom, pushes off the little thing in there.
Okay, that's the statistics for the second test. Much better than the first one. Okay. But it's just still, I would say, just normal behavior. Okay, the average is about 60. Yeah, the average is 62. Okay, so it's normal, but cannot say good. Okay, much better than first one. So again, let's go over the test problem quickly. Do you have any question here for the test? Okay. Again, what I would like to say that it seems that there is a pattern here. For many of you who didn't do very well, it seems that okay. For example, something I can see that some of you did pretty good for part 1 and part B, but really bad in part 3, and others did good in part 3, but not part 1 and 2. So it seems that when you try to prepare for the test, you either emphasize in the conceptual part or only in the problem solving. Okay, but to get a good score, you need to do both. Okay, so you need to review both the notes, the textbook, and working out all the problems. Okay. First, the part 1, multiple choice. First problem, a ball is dropping from the top of a building. Which of the following quantity will increase? So, A, mechanical energy, B, kinetic energy, C, potential energy, D, acceleration. So, A, mechanical energy. How about the mechanical energy? What is it? Increase, decrease, or keeps it constant?
Constant.
Mechanical energy, okay, should be a constant quantity. Okay, it will not increase or decrease. So, because that's summation of the kinetic energy and potential energy. Kinetic energy will increase and potential energy will decrease. But the summation of the two will keep a constant. So the answer is B, kinetic energy, it will increase. C, potential energy will decrease. Okay, so most of the wrong answer will be D, acceleration. Okay, will acceleration increase?
No.
For free falling, it's a constant. For falling with air resistance, it may decrease, but it will never increase, right? Okay. And 2, consider a completely inelastic collision for 2 pores. Which of the following statement is wrong? Okay. The answer is A. The final momentum is smaller than the initial momentum. Okay. Because for any collision, the momentum is conserved. So the final momentum should be the same as the initial momentum, right? Okay. And final kinetic energy is smaller than the initial kinetic energy. This is correct. Okay, it's not wrong because for inelastic collision, you will have energy loss. So final kinetic energy is smaller than the initial kinetic energy. Okay, also for a completely inelastic collision, the energy loss reaches the maximum value. So D is correct. And of course, by definition, after a completely inelastic collision, the 2 pores should stick together. Okay, so B, C, D, they are correct statement. So the answer should be A. What is the value? Problem 3. What is the value of coefficient of restitution for an elastic collision? Okay, so for inelastic, what we know is that for elastic collision, C equals to 1, right? For general inelastic collision, C is smaller than 1 but greater than 0. Okay. For completely inelastic collision, C should be 0. Okay. So for elastic collision, C equals to 1. Problem 4. An inelastic collision conserves. So it asks you 2 quantities, momentum and kinetic energy. Which one will be conserved and which one will not? And we're asking inelastic collision, so it conserves momentum but not kinetic energy, right? Momentum is always conserved for any collision, so it's always conserved. And for inelastic collision, you have energy loss, so kinetic energy is not conserved. And problem 5, for 2-body inelastic collision and a frictionless horizontal surface, which of the following quantity will not be conserved? Okay, we're asking which one will not be conserved. First, let's look at A, total momentum. Is it conserved? It should be. For any collision, momentum is conserved. B, total gravitational potential energy. Is it conserved or not?
Yes.
It's conserved because we emphasize that's a horizontal surface. So all the collisions, so all the things before collision, after collision, they are in the horizontal surface. There is no height change, so there is no potential energy change. It's conserved. D, the center of the mass velocity, is it conserved? Should be, okay? If momentum is conserved for the total system, then the center of mass is conserved, okay? Center of mass velocity is conserved because the total momentum P can also be written as total mass multiplied by the center of mass velocity. Okay. So what happens is that during the collision process, the momentum for each individual object will change, but the total momentum is conserved. So total velocity, the velocity of the center of mass is conserved. So the only quantity will not be conserved is C, total mechanical energy. How do you know that the total mechanical energy is not conserved?
Because it's not an elastic collision.
Okay, so total mechanical energy E equals to the kinetic energy plus the potential energy. Potential energy is conserved in this case, but it's inelastic region, so you will have kinetic energy loss. So of course you will have total and mechanical energy loss. Okay. So this is conserved, but this is not. So total energy, mechanical energy is not conserved. Okay.